All right, so problem 4 says use the fact that the integral of du over a squared, the square root of a squared minus u squared is equal to arc sine of u divided by a plus c in order to evaluate the following indefinite integral. Um, so first thing is, notice that I have a constant multiple of 7, which I can pull out of the integral. So this will give us 7 times the integral of dx, I can just leave that on the top, divided by the square root of 16 minus 25x squared. And what you want to do here is basically label what's your a squared and your b squared. So your u squared. So you can make a little comment on the side here. You can say let a squared be equal to 16, and we can let the u squared be 25x squared. All right, so now that you have your a squared and u squared labeled, you can go ahead and find what's your a and what's your u. So your a should be equal to 4 if you take the square root of both sides, and your u would just be 5x, right? In particular, you are somewhat doing a u substitution here because if you notice, you're using a fact that you have du over square root of a squared minus u squared. So you need to figure out what's your du. But that's not too bad. Du is just going to be equal to 5 dx. And since your original integral only contains a dx, you can move the 5 to the other side of this equation. This will give you 1/5 du equals to dx. So if we do a change of variables now, right, this integral that I have in terms of x, if I rewrite in terms of u, it will look like the following. We'll have 7 over 5. So note that I get the over 5 because we have 1/5 du. That 1/5, I'm pulling it out of the integral as well. So it's 7 over 5. The integral symbol, du over the square root of a squared minus u squared. And using our fact, we're going to get 7 over 5. Oops, my bad. 7 over 5 times arc sine of u over a plus c. Now, if I look back at my side notes here, I know what's my u. My u is 5x. My a is 4. So when I put it all together, we get 7 over 5 times arc sine of 5x divided by 4 plus c. And that is my final solution to problem 4.